All right, so everyone, number 1 and 2 are function types, f of x, g of x. We're going to find type of function, domain, even, odd, or neither. We're going to prove it. When I look at number 1, I see what I might call a composite function. I see f of x plus g of x, or f of x minus g of x. I see a polynomial, a power, 3x cubed, right? And I see a rational, 1 over 2x. So I would take that this is some sort of algebraic or composite function. But everybody, if you find a common denominator, you guys agree with this? That this function could be written as 6x to the 4th minus 1 over 2x. I'll think of this as a rational, everybody. All right? I'll think of this somewhat as a rational too, okay? But with that said, it doesn't matter for that. So let's just call it an algebraic, okay? An algebraic function for the name type. Guys, the domain is easy. It's all reals except x cannot be 0 because the polynomial has a domain of all reals. So there's no limiting factor in that. And the only limiting factor, one for the rational, is the undefined portion, which is 0. So there's the domain. Now the hard part. Even or odd, okay? Even or odd, and prove it, all right? So I'm not gonna guess. Since I have to prove it in black, I'm gonna substitute in negative x, okay, into the function. 3 times negative x cubed minus 1 over 2 times negative x. You're gonna get negative 3x cubed. Negative is a positive 1 over 2x. All right, we'll factor out a negative. And then the million, we'll factor out a negative. And the $1 million question after you factor out a negative is this stuff in the parentheses, f of x. And if you go back to the top, it certainly is. And so we have proven this is negative f of x. So when f of negative x equals negative f of x, it is odd. So it's an algebraic function, composite, domain all reals not equal to 0, and it is an odd function. I think if you think of the powers, you probably could have picked up on that. All right, and everybody, one thing I got to make clear, is there a point at 0? Does it go through the origin? No, right? It's undefined at the origin, but it's symmetrical about the origin. This is an odd function. All right, the next one, and I'm going to erase the stuff as we do it now. Type of function. All right, everybody, type of function for this is, it's a root and a polynomial inside. So this is another algebraic or composite. You should see it as 2 parts. If you wrote root, I'd probably take it, but I see this as a composite, root and polynomial. All right, everybody, domain. I got to be clear about this. This is why, and I'm going to do even odd neither here in a second. This is why we take time with this. When I look at this, I really want you to see g of x as a composite function of 2 functions. I want you to see h of x, the outside function, to be the 4th root of x. And I want you to see the inside, and I'm going to, even though all books write it this way, I typically write it in descending power. Everybody, this is some sort of polynomial. Is everybody with me? And we know that the range, since it's x to the 4th inverted, we know that it's going to not go negative infinity to infinity. All right? In fact, it's going negative infinity because it's opening down. And I can tell you the top of it is 81 for the range. And again, this comes from, again, the mother function for x squared. We recognize that g of x, here's x to the 4th, right, which is x squared for the mother, x squared, x4, x6, x8. It's negative, whoops, it's one thing. It's negative, so it inverts, and then it's up 81. We also recognize immediately that this function has a domain of 0 to infinity, because the mother function for h of x is this. All right, so we can only plug in 0 to infinity. So we are limited to the range that is 0 or positive for this domain. Now someone in the class invariably is saying, Anderson, you're making this way too hard. I know that 81 minus x to the fourth has to be greater than or equal to 0. And you're right. You get x to the fourth is less than or equal to 81. You take the fourth root of both sides, right? Raise both sides to the 1/4. But remember, when you do that, you get a plus or minus, right, everybody? So it's 3. Sorry, fourth root. So it's 3. 81 to the fourth is 3. 3 times 3 times 3 times 3 is 81. And plus or minus x. But everyone, and I don't want to go through the algebra here, we should recognize that this gives you from -3 to +3. All right? So the domain on this function up here, x is an element, -3 to 3. All right? All right, last thing was, is it even or odd or neither? Any idea without a graph? Any idea? Guess? Even. It's a pretty good guess. I think it's even too. I do g of -x. Fourth root, 81 minus -x to the fourth. Oh, look, 4 times. It is exactly the same function. Therefore, it is g of x. I've just proven that it is even. Does anybody know what this graph kind of looks like? Everyone, I hope you kind of see that this could be a semicircle. This is a semicircle, and it's not exact, okay? But picture it as y equals the fourth root of 81 minus x to the fourth. Okay, change g of x to y, raise both sides to the fourth power. And then bring x to the fourth over. Okay? But remember, we're limited by the output and the domains, okay? Alright, but anyway, that's that. Even, odd, names, composites typically happen quite a bit, alright? And polynomials happen quite a bit, so we'll keep our eyes peeled. Alright, that's enough of that one. Next one, I'm going to go single page. Everybody, I gave you a little function. If I was to tell you to write the piecewise function of this, you would be mad. Right? Because you'd have a function from 0 to 4, that's a line, you see it? Then you'd have a different line from 4 to 6 going down. And then, I don't know what I made from C to D. Is that a parabola? I have no idea. It's probably a parabola, right? And you'd have a different function from 6 to 10. Alright? But I wouldn't do it that way, alright? I would just not even care, point blank. So I got this beautiful curve, and I said y of f of x is shown above, and I said sketch f of x minus 2. So in blue, the $1,000,000 question is what does that do? Shifts it to the right. So I got a smart board, so I can trace this. And all I'm going to tell you is that, whoa, there it is. Alright? There's the curve. It would be the same exact curve, just 2 to the right. This curve, hopefully you recognize immediately, would just simply be 2 up. So instead of being the blue curve, I'm going to leave it blue, but it'd just be 2 up. It would look like that. Okay? I think those two are pretty straightforward. So I'm going to erase that. Alright. These are the two usually that students struggle with seeing. Okay? So let's talk a little bit about these. Y equals 2f of x. Alright. The question is this stretching it or is it compressing it? You got to decide, is the 2 a multiplier on the y value or is it affecting the x value? Everybody, since it's on the outside of the function, this is stretching it like up. And here's what gets students, and I made it black. I will tell you right now, 2 times 0 is 0. A and C do not change. I don't care if you double 0. Do you guys agree? But at B, 2 turns into, or 3, that's a horrible 3, right? 3 turns into 6, and at D, 5 turns into 10. Ooh, well, hang on, let's do better at that last curve. Let me try it again. Straight, straight, pause. Here we go. Nah. There. It's still bad, but you guys get the point. I would take any of the ones I drew, by the way, for full credit on a quiz. All right, for a sketch. Everyone, that stretches that function vertically. Because this is why. I want to be clear now, on the next one, it doesn't stretch it in the y. The 2 is happening on the inside. Does everybody agree the domain of my function is 0 to 10 on the original function? Everybody, by putting a 2 on the side, I'm going to make the domain 0 to 5. And the whole curve is going to happen twice as fast. Because think of it this way, what happens when I plug in 5 for x? I get 10. F of 10 is 5. So 1, 2, 3, 4, 5. So point D is going to compress into here. Point C, which was 6, is going to compress into 3. Point B, which was 4, is going to compress into 2. And 0 doesn't change. Here we go. Boom, boom, boom. All right? It speeds up how fast the function happens. All right? And again, this is chapter 1 review. Okay, there are some problems like that in the review if you need some more practice with it. We want to see this compared to our mother functions, all right? All right, but that's a new, and again, those would be sketches I would take. And if you want to label, if I tell you to label points, be careful. I would call this B prime, C prime, and D prime, because the points aren't the same, right? Do we agree they've moved? So, all right, enough said on that. I want to talk about limits today. A couple of you guys were gone yesterday. I hope if you didn't watch the video, hope you had a good run. I'm sure, Trent, you did not watch the video. All right, limits are the idea that we are interested in how we are approaching certain points. All right, so yesterday we had a curve. You guys remember? A parabola, and it had a point on the parabola that was 2, 4, where f of 2 is 4. And we proved as we came from the left-hand side, and we proved as we came from the right-hand side, that the values got closer. As we got closer to 2 on each side, the values kept getting closer and closer to 4. And what we agreed on is we made a graph at the very beginning of one of the first class periods that had the same 2, 4 point in it, but it had a hole, a rational function. All right, and when we did the cancellation, it was an undefined value. And that while f of 2 does not exist, or is undefined, okay, D and E does not exist, or an undie, there was something happening here. As you approach from the right-hand side, or actually the left-hand side, and you approach from the right-hand side, this value came closer and closer to 4. And we came up with some notation yesterday. We started talking that it could look like this. The limit as you approach 2 of the function was 4. All right? So today we're going to talk about this limit idea. So everyone, I got to be clear. When I put this function on the board, f of x right now, if you had to guess a type, just looking at it, does anybody have a guess? X cubed, yeah. How about a polynomial? You're being way too specific. Yeah, how about, you're right though. I think it's probably a cubic. Let's just say it's a polynomial. Is everybody clear with that? And does it seem like it's continuous everywhere? Right on the domain, it's continuous everywhere on the range. Does everybody agree? So I'm a polynomial. It's cubic most likely because it's going negative infinity. Could be x to the 5th, 2 Justice. So it's not guess, but we'll call it a polynomial, but you're probably right. And we agree as we approach A, as we come in, and if you're not noticed, guys, this is always the left-hand side. Why is it the left-hand side? It's the left-hand side of A. As we approach the point A, as we come along the x-axis toward A and come up the curve, we are approaching up here. We're getting closer and closer to L. You guys see that? as we approach this way, from the right-hand side, we find that we're coming down. So I will tell you right now that this has a limit. As x approaches a of the function of L. This is pretty boring because based on my picture, everybody, what's f of a? L. We're going to call this a continuous function because as you move along, there's no jumps, no holes, no errors, okay? We're going to call this a continuous function. We'll start getting some of these words in here, all right? So we have a continuous function, so this is kind of boring. So let's change it. And let's make it a rational. And everyone, if it was a cubic, if it was a polynomial of x before, right, where it was continuous, we all agree it was this function, I just made it, does everybody agree? I just made it this function. We should all understand the idea that I just created a hole. Right? Because a is undefined, and then it's the same graph except those canceled. Right? Alright, a little blast from the past of pre-calc. Alright? Alright, but my question is this statement true still? Yeah. As we come down the bunny trail from the left-hand side, and we come down the bunny trail from the right-hand side, do we collide at L? Absolutely. So there is a limit here, all right? But the next question I'm going to ask, what's the value of f of a on this function? Does not exist or undefined. I don't care which notation you use. It doesn't exist. It's not part of the domain. But it still has a limit, okay? Oh. Now I'm going to make this into a piecewise function, all right? We're going to do this. Make it alpha. All right, so my question then becomes the same. As we come down the curve from the right-hand side, what's it approaching? It's approaching L. When I come from the right-hand, I said right-hand, didn't I? When I come from the left-hand side, I'm tired. Then I come from the right-hand side. Do you see that we're coming down the curve and we approach the A value, we still are coming to L. So it still has the same limit. Guys, what's f of a this time?
Alpha or undefined.
Nope, it's alpha. There's a point right there. It's just what we're going to start calling a removable discontinuity. We literally took the point out of the curve, removed it down here to a value. That's a removable discontinuity. Okay? And the other one is actually removable too because we just popped a hole in the curve, all right? We're going to talk about types of discontinuity here in the next week. All right? But as we talk about limits, this is what happens. And the key to these limits is that they come together to a similar value. All right? What can't happen is this, and this does happen. You guys ever think about how a switch works in math? Right? A computer is a big switch. Does everybody know that? It's zeros and ones. It's binary, right? You're either on or you're off, basically. So what happens when you flip a switch? There's no ramp, guys. It goes from, say it was on, to off at some value A. Okay? So you had it on, something turned on, and then some later position of A on the x-axis, so you turned it off. And I can call this L1. And let's not have the graph on 0. Let's call this L2. All right. So my question is, as I come down, I'm going to say it right this time. As I come down the left-hand side, what's the value as you get close to that, to A? The value is L1. Do you guys agree? As I come down the right-hand side, and I'm approaching A, and I'm coming this way, right? What's the value of the function? L2. Do L1 and L2 equal each other? Why not, Gravin?
Because the one keeps going.
Yeah, it's not even that as much as, guys, are they the same spot on the graph? Right? So guys, L1 and L2 aren't the same. So my question to you then, and I don't know if anybody has an idea, call it f of x again, the function. The limit doesn't exist. Can you picture me when we look at the left hand and the right hand, and I sometimes joke, if it helps you see it, picture two cars coming at each other. And the cars have to collide at the same value on the y-axis, and they don't. When the cars get to the point, boom, boom, this one's at L1, the other one's at L2. L1 and L2 are not the same. Okay? We need the left hand and the right hand to be the same. In fact, it's so important that they're the same that sometimes what we do is this for notation. You know, this is the left hand, this is the right hand. If I hold up my fingers, it helps me sometimes, right? The L. Okay, but everybody, so if I want to know the left-hand side, do you guys agree I'm coming from the negative side towards A? So if I put a negative not in front of the A, that'd be negative A, right? But up behind A. And if I really try to blow this up on one line so we understand, the sign's up here, okay? That's telling me, hey, check the limit as you come down the bunny trail just from the negative side, or the left-hand side. I'll tell you this one is L1. And the limit as x approaches A from the positive side, which is the right-hand side of f of x, is L2. And the limit as x approaches A of f of x does not exist. And I'll tell you why. It doesn't exist because limit as x approaches A from the left-hand side of f of x does not equal the limit as x approaches A positive of f of x. All right, everyone, you got to practice this because notation is critically important. Where you put the f of x, where you put the a's. All right, 10-point problem notation is 3. So in this class, you either start from 100% or you start from 70%. So you start from an A or a C. So you have to practice you're doing the notation correctly. And I am just completely nuts about this. All right? Because unfortunately in college you have to do this. So I just don't let you get away with anything. I'm probably tighter than some college professors, okay? But we have to picture now that we are filling these things up, all right? And again, rational functions typically happen quite a bit because those are the ones that have holes. I come back that polynomials just are not that interesting. Because if you think about a function that is continuous, let's make it a real high power for justice so you can't guess, okay? Some polynomial. I don't care where you tell me to stop on the x-axis. Boom. A. L. Everybody, as you approach that point from the left-hand and the right-hand side, it's getting closer and closer to L. And what's the value of the function itself at f of A? L. The limit and the function have the same value. All right, so polynomials often with limits are pretty boring. All right? Let's talk about one that's not boring. So here's one that I didn't give you the graph yet. So I want you to guess the limit at x is 1 for that function. Do we agree, guys? What kind of function is that? rational function. Do we agree it's undefined at 1? Okay, so I'll give you a couple minutes to try it. I'm going to do it 2 ways, all right? I'll pause the video. All right. So everyone, I hope you factored this, and then you have to make a choice now. You basically have 2 choices. You either have to guess and check some values, or you should have made a graph. All right, and I will tell you, if you factored this, this falls under a mother function. All right? So we would all agree right now that if I just look at the function f of x, right, that I can simplify this function, and I do it a different color because it's not f of x anymore when I do this, but it's 1 over x plus 1. X cannot equal plus or minus 1. You guys agree? So this is a rational function off our mother 1 over x. Here's our mother 1 over x function. Do you guys agree? And then since we have this x plus 1, this is 1 over x. I'm going to shift it 1 to the left. Do you guys agree? And these asymptotes stay, but I also know it can't exist at -1, +1 also, which means that that point is removed. Remember, we have a hole because these values canceled. There's a hole. So I have a hole here. So right now I feel pretty good about it. I get to this point, I'm like, oh yeah, heck, look, I can tell on this graph that the left hand and the right hand are approaching the same point. The question is, where's that point? All right. Everybody, if you don't see it right, I'm going to go through the table first, then I'm going to go through the fraction. If you think it's a half, you're right. All right, the question is, why is it a half? Because this graph, using the mother function and all this stuff we did down here for mother function graphing, doesn't tell you it's half. It doesn't. There's no scale to this graph to guess. But if I go to the top, and I was hiding something the whole time, right? And I blow that thing up. I didn't make a graph today, guys. Ooh, it has to be bigger. I know it's hard to read. I know it's a little hard to read. We'll try to go through it.
Could I get the following students please report to the office once the bell rings? Grayson Bolton, Gracie Gold, Taylor Golaxon, Charlotte Bender, Adeline Andrews, Tressa Goldley, Chastity Goldley, Chad Mansfield, Leanna Daniels.
All the high schools show up to the office, damn it. All right, come on.
Gunnar Reedy, Morgan Schneeberger, Pierre Davis, and Hunter Foster.
All right, here we go. Everybody.
Also, there is no middle school football practice tonight. Just a reminder, no middle school football practice tonight. High school football players and cheerleaders will ride the bus leaving right after school for their game, along with the cross-country runners who are going over for practice. Please remember to check your email. This way will continue. Seniors, please remember to check.
All right, it's undefined at 1. You guys see that?
We'll continue to send you important information through school email. Thanks, and everyone have a great weekend.
I went with equal spacing, and I know this is hard to read, so I'll put them in here. Because I tell you what, at 0 it's 1, and that doesn't help us. And at 2 down here, it was a value. But when you had to get really close. So I went at 0.98, 0.99, 1.01, and 1.02. We know it doesn't exist at 1. It was undefined. But when we see this, guys, as we're coming in, do you see how it's going to approach 0.5? But you don't need the table here because it's a limit when we make the cancellation. And this is just like we talked about on the secant line, f of a plus h minus f of a over h, remember? The secant line. That when we get to this point, if we cancel this and this, now we substitute 1, you have 1 over 1 plus 1. This becomes 1/2. And again, what's f of 1? Undefined, right? Undefined. Does not exist. Undefined. It's an undie. Okay? Everybody, This is section 2.2, which allows you to do a little bit of the homework. All the initial homework is not based on functions, it's actually just reading graphs. Okay? The homework for 2.2 literally is just like 1, 2, 3. We'll make the scale a little weird. Everybody, I hope that you can see on the graph that there is a limit here. Left hand and right hand both approach the same value. I hope you can notice that, and I didn't really draw this in the right spot, did I? I was in such a hurry. I would hope you notice there's no limit here, because there's a jump. The left hand is higher, it's 2, and the right hand is 1. Same thing on the next thing. The left hand now is 1, and the right hand is 3. But there is a value here again. The left hand and right hand both approach 1. Guys, you have the answer book. When you try it, I'll probably let that be the same assignment for Monday, all right? Not too bad. Everybody, are we on for Tuesday? I'm going to turn off the camera. Are we on for Tuesday, Albany and